Bit of a tragedy. SpaceCat is no longer spinning. A kinetic sculpture that will spin once every 2,000 years. A series of gear reductions powered by a synchronous motor. The first generation of SpaceCat used a DC Synchronous Motor, which isn't really a thing, but this little part here converts the DC into an AC signal. I did take the heat shrink off one of these. It's literally just a black blob underneath there. Generates a sine wave, apparently. But, predictably, you can see this one's already loose. This one's brand new. Threw the broken one away, but it's already quite loose in there. Did not last. So, of course, next time we used a larger one. This one runs on AC 100 volts. I was trying to use DC just for safety in the project if something you're going to leave running. But the idea is to leave this running forever, and this bushing here wore out. It's quite tight in here now. It's a hardened steel bushing. But after a while, with the starting and stopping especially, I do have the sculpture on a infrared little IR sensor. Well, I'll show you in the main one. So, this motor, also trash. So that brings us to today. We need to redesign SpaceCat's drive system to use a larger motor. That last one was 4 watts, this is 10 watts. AC again. I do have it hooked up for testing. AC power comes in, cute little grip, feeds into our IR sensor. Back of that has work all the time, run for 5 minutes at a spot. Both of those hook up to the motor, runs the motor. Also hooks up to a LED driver. I'm going to put a bunch of LEDs in here as well. Cooling fan. One thing about synchronous motors is they get quite hot. There's very low load, but it's just pumping AC through resistive elements. In order to combat that, I had a laser cut part made. Half heatsink, half housing, half mount everything. Just kind of look nice. These holes around the perimeter are the LEDs. And these 4 holes here line up. And the hexagons are there just to look pretty. A little more surface area. So designing an enclosure, I figured, is something people do reasonably often. I've already imported this guy, which has the center 100 millimeters from the base, and the base the same size as the existing mount. The other thing I did is grabbed all of my components and brought them in. So when designing an enclosure, the first thing I do is I design all of the parts that I want to enclose, and that way I can play with them and move them around. So the fan, see, that's a very nice model. Beautiful, accurate. It's because I downloaded it. You can generally find step files of most common parts. I probably could have found some of the other components if I looked hard enough, but it's quick enough to design. I mean, I made this part, so I already set the DX up of it just soon. And it's like, how do we want to build this around it? All we really have to do is seal it up. The way I was thinking about doing it is have everything feed in through one big hole here. So we're making a single part faced by this plate. I'll hold it in with maybe just some zip ties or rubber bands, something to class in. I might even just dab some silicone on there to make it. So one of the things I want to do is reduce vibration, make this a nice quiet machine. I feel like giving this a square cross section in the rear, having that come up for a ways and then fan out. So let's start there. You know, we're going to modify the motor because I think that will make my job easier. I'm gonna go grab a real screwdriver. So I can move that around to the base. I'm not going to drill holes in the base, and this would actually get too hot for hot glue, so I'm not sure the best way. You generally don't want the wires moving around, just better to keep them secured, but we'll plan to route that to the base because it fits nicely, and we should have our model reflect that. We're going to cancel that. I'm going to open up my synchronous motor and edit this part. And this does not need to be a high precision operation. We're not printing this, we're just trying to get a mock-up so that we can design around our parts. See the exclamation mark? I can get the latest version, and now we see that this just fits between those. Looks good. It is no longer on the side. We can't move these parts, or this part in too much. We can do it a little bit and move that over, because generally I want to streamline things, make it look a little bit smoother. Back to our offset plane. I'm going to be building up from this highlighted blue ring. If you try to make your enclosure as small as possible, it gets very hard to integrate, and I'm kind of thinking I need to shove my hand in there to get all the components. That's a 2.5mm wall. Use the loft tool. Take both of these parts and loft up. Always a much better look doing multiple lofts. One for the solid and one for the hollow. We do need to extend this base a ways. I'm going to go back in time to do that. And the only purpose behind that is that when we extrude this, we'll have some meat on it. Because it did not ruin anything. Never seen that before. So now we're going to make the holes for all the parts. So this fan is just not perfectly centered is the issue. So you can see we're off a little there, and there, and they're all in the same direction. So that's what happens when you get CAD files from the internet. They're not always perfect. I'll survive somehow. So the main reason to chamfer all this is to reduce the amount of support needed for that. We'll do the same 10mm round that we have on the outside there. You'll see I have little thick corners, base, and just going around and chamfering all these holes to make them look nicer. Just a 0.5mm, but that really improves the sort of feel and the look of the print. Oh, I forgot something quite important. I need to put something behind the motor mounting plate so it actually stays in place. It's a little late to be thinking of that now. I even planned on it, I just never actually did it. So that gives us the lip we need to have a mounting plate, and there's nothing behind it, but that's just fine. It's pretty cozy in there, but I think that's worth a print. We'll see how it goes. Let's see what it does with support. I feel like it's going to go crazy. And that's not terrible. Kind of don't want support on the bottoms, but whatever. Give me a brim too, though. Hopefully it works. Happy printing. What up? How you doing? So this is the SpaceCat of the infinite spin. And the old motor unit died after about 6 months of operation. So we're going to replace it with a new one. Only slightly larger. They're basically all the same components as the new one, but this is DC. Weak. Small. There's what this looks like underneath the, oh, look at that. Apparently that's what failed. So maybe the motor's still good. Oh well. Still gonna put the bigger one in, because spent all the time making it. RPM here, 60 RPM, 1/5 of that, so 6 minutes. If you, I can repeat this guy's got quite a lot of torque already. I think I can stop everything in there. Yeah, I do that. So this is SpaceCat of the Infinite Spin, sort of tribute to Arthur Ganson. He did something called a machine with concrete, where it went through a whole lot of gear reductions, just like this, except his were worm gear reductions. I don't remember how long his would take to spin once, but I thought it would look cool with planetary. So we start here, we're at 60 RPM. These guys were for the original motor, which has been long dead. This guy is 1/5 of that, basically 0.923 to 1 is the gear ratio. So 60 divided by that, times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So basically 60 divided by 5 to the 17th will give you your rotations per minute. Basically none.